So in a previous video we made this graph about the effect of temperature on absorbance of beetroot pigment. Now we're going to go and look at describing the data and then analysing it. So firstly, describing it. This would go underneath your graph, really still in the results section. 4 things I want you to talk about in terms of describing it. First of all is the overall trend. If we were to put a trend line on here, we would see that it would go like that. So as the temperature increases, the absorbance increases. The second thing is to talk about any variation in that. You see the 30-degree trials, the value is much lower than that trend. Probably also the 50 degrees, maybe a little bit lower. Or, that might be that 40 is a little bit too high. But probably the main trend here is that the 30-degree trials are much lower than the described trend. The third thing to talk about is the size of the error bars. So these are the error bars. For the cold trial, which is about 7 degrees, and then at 30 degrees, the error bars are very, very small. The trials for room temperature and for 50 degrees are moderate in size, and there's a very, very large error bar for 40 degrees. Now, the last thing we want to do when we describe the trend is to look at the overlap. So what I mean by that is overlap between the error bars. So you can see here's the trial for room temperature, and if I run this across here, you can see that it overlaps with the error bar for the 40 degrees. And equally so does the 50 degrees. So that's describing it. Now what we need to do is analyse the data. So let's firstly consider what standard error of the mean means. It's basically variation in the mean between the trials. So if we've got a very low error bar, it means that the data, there was very little difference in the data between each of the trials at that temperature. So if we have a look at this is our 7-degree data, there's very little change there between them, and so therefore we've got a small standard error of the mean. Whereas have a look at this one for 40. We've got a 0.9 versus a 0.157. So there's a huge difference between these, a huge variation. And we can actually even pinpoint that one and say, well, that's our trial that is significantly different to everything else. Okay, now, so let's talk about what that means. So we've got a very large error bar here, and it means that there's a large variation between the values for each of the trials. So, so that means that there must have been some sort of, random error that that was introduced for one particular or a couple of trials, because there's a large difference between them. Whereas for these smaller ones, it means that there was very, very little difference between the values for each of the trials. Now, overlap. What does the overlap mean? Well, overlap is actually really important for us. So if we have a look at another example here, we've got, this is reaction time compared with different houses at our school. And we can see that these two error bars, there's significant overlap between them. So here's the language you want to use. Where there's overlap between the data sets, it indicates that we cannot say that there's a significant difference between the two sets of results. So significant difference is important for statistics. We cannot say that there's a significant difference between these. So what does that mean? It means that the variation, or the pattern that we see, may purely be due to random chance and not related to the independent variable that we're changing. Where there's no overlap between the data, it means that we can be confident that there is a significant difference between the data. Or in other words, that the difference that we see is related to the independent variable and not due to random chance. So let's have a look at our data then. Now, so there's overlap between the room temperature, 40 and 50 degree. So that means that we cannot be confident that the trend that we see here is related to the independent variable. So changing the independent variable temperature, we were expecting to see this trend. However, because there's such variation in our results, we can't say for sure, we can't be confident that the pattern we see is not just purely random chance. We can't say it's related to the independent variable. Now, the other thing we can say here is like this data point here is really low, lower than we expected. So all of the trials had very similar data, but they were all lower than expected. So this means there must have been some sort of systematic error, an error that was repeated for every trial. Because it's low, we need to think about, well, what sort of errors could lead to decreased absorbance? Not having the beetroot in the water for long enough, having the temperature lower than the expected 30 degrees would have reduced absorbance. Another one might be if all of the pigment settled at the bottom of the test tube, and when it was decanted into the cuvette, it was just the water at the top that went through into the cuvette, and the solute, the pigment, remained at the bottom of the test tube. So look, we can only speculate in terms of what that was, but it's a systematic error because it's the same error repeated for each of them. Another one, of course, is it might be that the beetroot was rinsed for too long. Like, for example, if all of the beetroot was in a beaker, rinsing away, but it was left in there for too long, well, all of the beetroot pigment is going to diffuse before you start the trial. It's also worth speculating about why this one is so variable. And if we have a look at the data, we can see that there's just one point here that's significantly higher. We can only guess what that error could have been, but it was much higher absorbance than could possibly be expected. Was it that the beetroot was in the water for too long? Was it there was a lot of beetroot in there? It's so much higher. I wonder if it was just reading incorrectly on the spectro, or maybe the cuvette was put into the spectro the wrong way. So it's a random error because it only affected one trial. Alright, so the next thing you need to do is talk specifically about those errors and then make recommendations about what can be done in the future to correct those errors.